the topic, how to become a great Meetup speaker. And you might be thinking, oh, why is that one of them in brackets? Well, it's because really, I don't want to be standing here and saying that there are great speakers and bad speakers or whatnot, and you have to be like perfect to do a Meetup or whatnot. The idea is more like how to become a speaker at a Meetup. So, and obviously the grade is a good plus, and I think pretty much all Meetup speakers are great. So I'm going to get back to that later, but that's kind of the point. Yeah. So first, a quick word about who am I. So I am, by day, I am commercial marketing manager at Microsoft in Finland. And also I'm one of the co-organizers of this Meetup. And in the past and currently as well, I have helped a lot to organize a lot of the Finland Azure User Group Meetup activities, as well as I am a Meetup veteran and a tech enthusiast. So I go to a lot of Meetups, a lot of events, and I've essentially done 7 years of tech events, organizing them and attending. So I do have to say that if there's one thing that I've done is attended a lot of Meetups, so maybe I can say that I know something a bit about how to speak at them. Yeah, and I have given and spoken at Meetups, giving a live technical demo as well, so I do have experience on that side as well. So, why this particular topic? Why should you care? That's a good question. And I really think it's because I think everyone has a tiny bit of like rock star inside of them, and everyone wants to share their passion. They want to talk about what they do. They want to be in front of their peers and be respected for what they do in their field. But even if you don't, even if you wouldn't have that kind of passion or an interest to speak publicly, I think you can take a lot of the things that I'm speaking in this session to your own life and then use them in that front. Yeah. Then there will essentially be 9 tips in this lightning talk. And actually, number 1 and number 9 are gonna be the most important ones. The rest is good, and that's like nice and dandy, and I think it's valuable, and I think we can all go through them. But I think number 1 and number 9 are the actual ones that matter the most and are the most important out of them. So, to start, what makes a great speaker? I think that's a really good question, and then to figure out like how to become a good Meetup speaker, I think that's a good question to start. And I don't think there's anything that we can say. You could say that, okay, there's certain charisma or bravado or something about a person's character, like people are drawn to them or something. But I think there are so many ways that you can do that, and everyone can do that on their different styles. So I have a few examples there, but you know, Obama, for example, they have a very different style than usually, you know, some hyperactive speakers who are running around. He's very calm, he's very collected, he takes his time. So that's one style of speaking, and that's totally valid. And obviously, I think one of my favorite examples is the Finnish Minta Liukas. She has a lovely style of like, she's a bit nervous, and she has spoken about that she's a bit nervous before all the speaking engagements, but she embraces it, and she kind of goes in there and she takes the nervousness energy and smiles a lot and kind of like interacts with the audience, and I think that's a really marvelous way to do it as well. So it connects to the first tip, which is be yourself. So that's, I think, is the key, especially to Meetup speaking. So everyone has a different personality, everyone has a different kind of speaking style, so it really is about being yourself, whether you be, you know, the peacock or the goldfish or the turtle or whatever that is, but how you speak normally, how you do it. Because we are here with our peers and we're here together, so everyone can find a style that they can, you know, enjoy and just share to the community. Then we have decide on a topic and passion. So that's obviously a rather clear one, but I do think it's important because there can always be this kind of, oh, I want to do this, I want to do this, I want to speak at a Meetup, but then you really do have to just decide a topic and maybe something hopefully that you're passionate about, that you know something about, a project that you worked on, or anything for that matter, that really is something that speaks to you. Then, important thing also is to simplify. So we're all experts, we all know what we're talking about, but then obviously it's good to maybe boil that down, give it the absolute most important talking points, go with them, and create something that's understandable and relatable to the people in the Meetup. So then think about the flow of your talk. how does it flow throughout the whole presentation, because essentially a talk is a journey, so you can take the people on a journey and build upon that and create some things. Yeah. So, and then there's connect. So I think it's super important to talk with the audience, ask them things, and connect with them. So while I was doing my technical talk previously, some of you might have been there, I don't know, but I asked the audience in the beginning, have you done something about this tech before or whatnot, and I think that's a really good way to do it. Because essentially, talking can be nerve-wracking, and then just connecting with people is, I think, a really good way to start. So, a very obvious one, I think, but I think still think it's super important, and I think that goes for all things that you do, obviously. So preparing and practicing. And I think especially for if you're doing a live demo, it's super important, because then you need to be confident in what you do. So when I did it last time, I actually prepared it to such an extent that I had all of my things that I was going to speak about printed out, because I was like, okay, what if I get nervous, if I lose my words, or something happens, or something weird goes wrong. Then I had everything printed out, and I knew that I would be able to say it, even though there would be something, there would be weird internet connectivity things or whatnot. And it's a cliche, but I think everyone should trust themselves, so that's, I think it's super important as well. So everyone can do it, and everyone should be able to trust in themselves and be the diamond that is in there as well. So, and then talk to people, ask for their help. So I think, for example, anyone here, we can kind of bounce around ideas about potential topics. So you can speak to any of the people in the meetup and just like talk about it, speak about it. And also, I am super happy to help if you have a topic in mind that you want to speak about. I think Lucas is super happy to help. We can even like spar with you and go through the presentation beforehand if you want to kind of see if your topic is interesting or if it's not. Just kind of go through it together and see if there's something that we can do about it. So, the 9th tip, which was super important, is just do it. So essentially, that's all you need to do. Like, come to talk to us, just talk about it, get it done. Because if you just think about it, it's never gonna happen. So it's important just to do it, set the date, and start doing it, practicing, making out what kind of topic you wanna do. And in the spirit of just doing it, here is the link that you can submit to a topic to speak at a meetup in this one. And if that's a bit too scary, just come and talk to us and we will see if there's something, as I said, on your topics that you want to do it. So, as a recap, the 2 most important ones, be yourself and just do it. Yeah. Thank you.
All right. So this is actually a talk from an earlier conference from London Jack's conference. I made it a bit shorter and everything, but essentially all the important things are still in there, hopefully at least. So basically I'm going to be talking about a bit on sort of security aspects, and especially from the point of view that we're pretty much everybody doing DevOps today, right? And DevOps is all about automating things, going super fast, and hopefully not breaking things, at least not too much. And I'm going to be sort of taking the approach that okay, developers are pushing things super fast. How do we make the cluster secure, and sort of how do we protect the cluster itself so that the developers don't go and shoot themselves in the leg or the face? Well, safer at least. There's like a zillion different ways how to work a Kubernetes cluster, so I'm not going to be covering all those today, but at least some bits and pieces. So first of course we'll take a really super quick look on what I mean by scissors in Kubernetes and in containers, and then a bit on securing the cluster kernel, RBAC things, how to enforce the workload configuration to be actually sort of secure at least, and then a bit on hoarding. So yeah, if you're super lucky, you can just do your cluster in kubeadm, create the cluster, and run around like your beer gal here. If you're super lucky, you might be able to run for 10 miles. If you're not so lucky guy like me, I'll trip over in the first 10 meters and probably kill myself or something. And then if you've been setting up your own Kubernetes cluster, I mean, doing it the sort of hard way, you see that there's quite a few knobs to turn on different components. So I actually did some numbers, I have to check them out. So on API server, so these are from 1.13 something release. So on API server, there's 162 flags to set up.
That's true.
On kubelet, which is the most important piece of the puzzle, basically. 185 different flags to set. So go figure it out. Good luck for you. And there was actually a study from, I think it was from the Microbadger team last year. So 86% of the images on Docker Hub are running as root, which is a freaking bad idea, but it's there. And what makes it super bad in Kubernetes is the fact that root really is root. So in Kubernetes, we cannot use the Docker remap user namespace feature at all. With the remap feature, you could actually run or the processes in the container could be looking as root, but on the host side there's something else. That's not in Kubernetes. It was planned for 1.14. It didn't work out. Looking at the discussions on the KEP, the Kubernetes enhancement proposals, I wouldn't bet on landing it on 1.15 or maybe not even 1.16, but hopefully it'll be there, but I wouldn't hold my breath waiting for it. Maybe Lucas has some better inside information, but
16, yeah, I think.
Yeah, let's see.
But yeah, but still, it's like you don't get root privilege on a host, but if you do privilege through, like that nice. Yeah.
Just don't do it.
Yeah. All right. Well, let's see. So, as you probably have been working with containers and Docker, you probably stumble on these capabilities. So it's basically a concept in Linux kernel where you can actually define sort of shades of gray, and not in the way of 50 Shades of Grey, but shades of gray between on root and non-root, which is basically black and white thing. So the capabilities can have finer grained control on what the processes can actually do, whether I can bind to a port, whether I can do a join or something. And one of the problems with containers is that by default, there's a lot of capabilities set on a given container running. And then you can always have the privilege true flag on, which gives you all the permissions. I'm sure that everybody in this room has done privilege true at some point of life. I've done it. So, just as an example, this is sort of a mimic from a talk Liz Rice did in KubeCon Copenhagen about a year ago. So, I basically did just a simple Nginx image, just added one library to actually get something out which I can use to inspect the capabilities that I have in a container. I put it running with the, as you see, just the plain default configuration on pod. And when I check up what's happening inside the pod, inside the container running, who am I? Well, I'm root. And I have quite a few privileges to do stuff. I'm still on a container, but I'm actually root, and the process is running as a root on the host with a lot of different capabilities available. So, sounds like a bad idea to me. So yeah, pods are just not safe by default. I think that's actually the most important slide of the talk. That's a pod with default configuration. So yeah, let's take some of the scissors away. Of course, the most important thing is the cluster kernel, the core Kubernetes components themselves. So use benchmark tools like kubench, kubehunter, Sysdig, what's the Sysdig tool called? Falco. Yeah, there's a bunch of others too. So basically those are tools which you can use to inspect the security settings of your cluster. So they give a nice detailed report that what should I go and fix to prevent nasty things happening. And of course, lock all the doors by default. Don't run a open white kubelet API on internet like Tesla guys did. So their cluster got hammered with Bitcoin miners. So yeah. All right. So one of the things to watch out in the cluster kernel, of course, is to have the authentication and authorization configured properly, and that's actually pretty tricky. So you actually do have to spend some time figuring out how to do that. Unfortunately, if I would go into all the different flags to set, we'd be here still tomorrow. So you just have to do a lot of reading and understanding how authentication and authorization actually works. And of course, ensure that everything has a proper TLS in the system. And for me, one of the sort of weirdest learnings in the past few months was the fact that kubelet is by default running a self-signed certificate on the kubelet API. So whenever you do a kubectl exec on your command line, the call goes to API server with proper TLS probably, but from the API server to kubelet, it goes to a self-signed certificate TLS, which is a, well, I'd say good. Yeah. And actually, I do have to put in a sort of advertisement. So we actually did an open source component to help to configure kubelet with a proper API server CA certificates. So check out the thing called kubelet rubber stamp. It's open source on GitHub, so it helps you to put a proper TLS there. And don't expose the APIs to basically to internet. Make sure that the cluster internal APIs used, even though they would be secured, make sure that you don't actually expose them to internet. It's just a bad idea. Okay, RBAC, basically who can do what, super fine grained, and it's usually scoped with namespaces, so it helps you to actually secure things, but there's always a but somewhere. As RBAC is super fine grained, that's also part of the problem. So, and that's just a couple of examples on different RBAC rules for different components in the cluster. So you see that it actually gets pretty long and complex, super fast. So it's basically a sea of YAML. And one of the things I've been sort of struggling with is the fact that I haven't found a tool which I could use and basically ask the question from API so that I'm Jussi, what can I do on the API? There's unfortunately no such tool available yet. Yeah.
There is like command line tool.
kubectl who can.
Can I something?
Is there?
Yeah.
Okay.
You cannot actually be fine grained as okay. I list all the things that I can do, but if you do the kubectl, can I list get services?
Oh yeah. But that's pain in the ass.
Yeah, that's.
Excuse my language. That's pain in the ass to use. Yeah, I know. Yeah. I want to have a list that what can I do?
Yeah. Write the tool then.
Yeah.
Pretty much.
Yeah.
Bash loops, anyone?
I feel the pain already. There are some helper tools. So, for example, the RBAC manager simplifies the RBAC rules so that you can actually work more easily with the different rules and bindings and whatnot. It actually makes your life easier. It doesn't take all the pain away, but it makes your life easier. And then there is this tool called kubectl who can. So it essentially gives you a list that who can do what things, but it still doesn't answer the question that what can I do? It's sort of the same direction, but maybe I actually need to find some time to work on that. So yeah, to make the workloads a bit more secure, we can always put in these security contexts in the pod definitions. So we can say that, okay, whatever we run in this pod, we don't allow it to run as root. I'm really sure that there's a lot of other folks than me in this room that who just doesn't remember to put things like these in the pod definition.
Yes, that's why we need admission controls.
Yes. So, and one of the admission controllers is a thing called pod security policy. So with pod security policy, PSP, so it basically acts as an enforcer, sort of a bouncer in the API, and decides which sort of pods it lets into the cluster or kicks out from the cluster. And it can also set some default values. So I can set a PSP defining that, okay, no host network, no host bits are allowed, no root users are allowed, and whatnot. So it gives you a pretty fine-grained control. But there's a lot of pain in PSP, unfortunately. And when you start to work with PSPs, be sure to work in Minikube or local cube or something, and don't try it first time in your production cluster. I'm almost certain that you'll actually cap your cluster.
Are you speaking from experience?
Yes. So, what actually the problem comes from is that what of those policies gets enforced, it's actually selected to RBAC rules, which you saw that can actually be pretty complex. And when was the last time you actually, in production, when was the last time you created a pod? kubectl create pod? Nobody does it. It's always some happen. Check. There's always some controller creating the pods for you, which means that whatever RBAC role the controller is using has to be configured with the proper pod security policy. And when you have a lot of different controllers and operators and whatnot in the cluster, it gets complex. So learn how to use PSPs, learn how to use them, learn how to configure them in some other environment than production. That's just one example how these PSPs gets configured. So there's this special use verb in the roles defining that, okay, this role is using this policy. And yeah, the last bit is about hoarding. So it's easy to, as a developer, just to push sort of random stuff in your cluster, and by doing so, you actually exhaust all the resources in the cluster. So resource quota is a tool, let's call it a tool, to limit the aggregate resource consumption of a namespace, for example. And yeah, it's yet another admission controller, so it's basically not a set of bouncers in the API, whether to let your pods and deployments and whatnot into the cluster or not. So you set limits on CPU, memory, storage, object counts, whatnot. And then in the resource quota, you can say that, okay, there's a limit of one CPU core in this namespace, 1 gigabyte of memory, and so on. So whenever you are creating a new pod or something, the admission controller, the bouncer, basically calculates that, okay, you've created already this much, does this fit into the limits or not? And then whether it fits in the limits, yeah, go in. Doesn't fit in the limits, go to some other bar. Another sort of similar, or well, not similar, but another sort of tool or concept is a limit range. So with a limit range, you can specify what are the default limits for a pod created in a namespace. So it basically is a tool to allow you to have some default, whether they are sensible or not, but at least some limits on every single pod in a namespace. Of course, if you're running in the same namespace, you're running Java apps, Golang apps, yeah, go figure out a sensible default for that, but at least it gives you a way to have some limits set on the cluster or a namespace. So, secure the cluster kernel, make sure that you actually understand how authentication works, how RBAC works. Maybe use the RBAC manager as a helper tool. And yeah, learn all the 184 different knobs to turn on different components. And yeah, for namespaces are a thing which you should really use heavily. So to scope things and create sort of a boundaries within the cluster. And for any given namespace, ensure that you have quotas set, you have proper PSP set up, you have network policies, which I actually didn't even have time to speak at all. Make sure you have some default network policies in a namespace. Use limit ranges, and your life will be safer. I won't guarantee that it's safe, but it's going to be safer. Or your developer's life will be safer. They won't cap the cluster that much. They will do it still, but not that much.
There's always a way.
There's always a way, yes. And yeah, so one of the cool things with Kubernetes is that you can customize it pretty much. And one of the ways to actually sort of enforce all of this would be by writing a custom admission controller, which would be another bouncer in the door, inspecting everything, whether everything fits into your policies. And you can also define these custom operators, which would actually be able to react on a creation of a new namespace. And an operator would go and configure the namespace properly, put in quotas, put in PSP policies, put in everything in place to make a namespace secure by default. I've been planning on working that sort of an operator, but I just haven't had any time yet. I've been planning it for the last few months already, but haven't found any time yet. Let's see.
Yeah, but generally I think as Kubernetes mature, such higher level stuff will start popping up in different places,
yeah,
which is good. And then eventually in like 2 years more will be mainlined in some way. But
yeah,
until then, like there's, as you say, pains.
yeah, yeah. All right. That's a really short and quick version of the talk. Hopefully at least I gave you some ideas. I know that I didn't give a lot of answers, but hopefully at least you have some ideas and things on a checklist now that okay, I really have to check our cluster for this and this. Thanks.
Thank you.
About getting your developers to adopt your service. And here's the me slide. I was taught that this is what you should do. So I'm an infrastructure engineer. I work with Kubernetes. I work with providing logging as a service and container orchestration as a service to engineering teams within my company. It's not something that we sell something else. I've been working at Meltwater for 3 years, and I've been on this team for more than 1.5 years now. And these are different ways you can contact me if you're interested, if you want to share your thoughts on the talk, or if you just want to reach out and chat about the things I tell you about. And the Slack icon, it's like the Cloud Native Nordics, it's the CNCF, it's Kubernetes, and on most of those I'm just Jessica and you will be able to find me. You can also tweet to me or send me an email. So where do I come from? I come from Meltwater in Gothenburg. Meltwater is media insight, PR, quantifying. It helps you to know like the reach of your brand, compare you against your competitions, etc., and connecting to influencers. The reason why I tell you this is because, as I said, I'm not selling Kubernetes to you. I'm selling Kubernetes to my coworkers. I'm also selling you this because what we sell is that we get a lot of data, and then we do a lot of, like we enrich it, we sort it, etc., and then we make it available, and we try to help you gain insights. So there's a lot of pre-processing and there's a lot of post-processing on the data that we gather, and also like storing all this data. So we handle a large amount of flow of data every day. These are tech offices. I learned today that we apparently have an office in Helsinki. I should have guessed, but these are the tech offices that we have, and as you can see, they're spread out all over the world. And we're about 450 employees in product and engineering, and we are spread over more than 50 teams over 12 locations. And I will get back about the challenges regarding this later on. So the mission of my team is to enable the teams to accelerate without thinking too much about the infrastructure, allowing a rapid path from ideation to prototype to providing business value. Or a lot of, very nice words put together. But the point is, what we try to do is that we try to make it easier for fellow engineers. We try to create a paved road for them and to have them not reinvent the wheel all over again. We try to make it easy to, if you want to run a container somewhere, you shouldn't have to figure out like, oh, where should I run it? Is it like just Beanstalk? Is it EKS? Whatever. And we try to make it as easy as possible. We also try to provide a lot of materials so you will not feel overwhelmed by getting started. As all of you probably know, Kubernetes is quite big. If you start to, I want to run a container, now I have to learn Kubernetes. That's not what you want to do as a developer. As a developer, you just want to run your container somewhere, not just learn everything about Kubernetes. So the title has adoption in it. And why do we care about high adoption rate? Well, for us, it's kind of like, how good are we doing, or how well are we doing your job? Like, how good are we doing this? Because if we have a high adoption rate, then that probably means that we did something good for our fellow engineers. We probably provided great value for them, and we probably made their lives easier. And that's something that we care a lot about. So if you care about high adoption rate, ask yourself, why do you care about high adoption rate? Is it because you want everyone to use your cool service? Maybe you're doing it wrong. Try to figure out why they should want to use your service, right? So let's look at this map again. My team is located in Gothenburg and Budapest. We only cover one time zone. Yeah. So it's when I head home for the day, my coworkers in San Francisco start the day. That means that we have a full day delay anytime we want to work on something, anytime they have a question on something, anytime they have a feature request, or they just want to know, is this possible? Will it be coming? The same goes the other way around, and it's just very much a mess, to be honest. So this is like one of the biggest challenges that we have to handle, not only delivering something of value, but also over multiple time zones and locations. Every one of these offices, of course, we talk to each other, we have Slack, we try to communicate a lot, but it's still a huge risk of it being isolated and having silos, where knowledge gets stuck and not shared in between offices. So let's talk about the service. Maybe you guessed, it's Kubernetes, right? But I want to start somewhere else first. One of our first paved roads was Mesos Marathon. And this was a while back, and by that time it was the best option out there. I don't know if anyone runs Mesos Marathon here. I still do. Yeah, there's a few. I'm glad we can talk later if you want to. But for us, this was the first step towards autonomous teams. Before we rolled out Mesos Marathon, we had the developers, we had the operations, and then the developers built something and the operations deployed and run it. And the developers had very little impact on what happened in the production environment. And when we started running Mesos Marathon, that gave the developers a chance to actually build the containers themselves and deploy them, and to structure that. And this was like the first step towards autonomy, and it was great. And since then we moved fully there, which means that all our teams that I want to sell Kubernetes to, they can just say, no, I'm going to go do something else instead. So I had to actually convince them that this is the best option for them. So when we moved to the cloud, we were running in data centers when we set up Mesos Marathon. Then we did a company directive that we're going to use AWS. So when we moved to the cloud, we decided that we should set up Kubernetes instead. And I'm very happy with that choice. And we started, as I said, 1.5 years ago, and exactly 1 year ago we went GA. That means that we told everyone that it's stable, please deploy whatever you want, anyone who is welcome, just send in all your containers to us. I also want to share about our size of our cluster, so you do understand. We have one, oops, that was too early. We have one production cluster where we have everyone. So we have currently about 27 teams that are onboarded to Kubernetes. And they are spread over 82 namespaces. Those probably contain the system namespaces as well. But most of the teams have around 3 namespaces each for development, staging, and production most of the time, or something equivalent to that. We do auto-scaling on our nodes. That means that 189 is the number that was yesterday. It could be something else today. And we had somewhere around 2,500 pods, 600 deployments, like 400 something services, etc. I know it's not that big, but it's, slightly big.
Right.
Come on.
Is that running on top of AWS? All of it?
It's running on top of AWS. We're running it. We are managing it using COPS, and we self-managing. So we run it on EC2 instances. I would love to answer more questions about how we configure a cluster and what settings we have, what instance types we use, etc. But that's not part of this talk, so come ask me later if you're interested. So, what did we do then? Think back. Think back to like March last year. We had been doing the research phase. We had started we had played around Minikube a lot. We had started up our own clusters, destroyed them plenty of times, etc. And then we felt like, okay, so now we know enough. We need to start getting someone to use it so we know what matters the most next. So we decided to have a focus week. And when we say focus week, we mean that we get 2 teams in one location and we work together for a week towards a specific goal. In this case, the specific goal was to move one of the staging services from Mesos Marathon into Kubernetes. That meant that we had to solve issues such as network connecting between the data center and AWS. We had to figure out how to deploy it, how to do the configurations, how to get the logs, the metrics, etc. And it was really great because we really did discover the things that this team used, the things they needed for the daily work, and they were very clear on what points pained them, like when they started using it. Why do I have to do this? Like, how does this work out? Etc. So it was a very good way to start connecting early on with our customers and to understand their use case. And I would recommend anyone starting out with delivering a service to especially work closely with your end users. And talked earlier about authentication, and of course we also wanted to do that. We started out using certificates. So we created certificate files where we baked in which namespaces each user should have access to, and we put them into secure ways and distributed them to their users. And when it was at one team with 4 people, that was fine. When we moved on to onboard the next team, it was very painful. And then this was not a user requirement, this was our requirement. We did not want to onboard 400-ish people and 50 teams using certificates. So there's a lot of different tools out there as well. You can use IAM to identify. But our human problem is we use GitHub. So we have a GitHub organization set up, and this is part of the onboarding and offboarding process of all developers at our organization. So this is something that we already use. We set up teams, this is how you get access to your repositories, etc. So we knew that we wanted to reuse this authentication because we don't want to set up something totally new. So we looked into combining that with DEX, which is a tool that helps you use the GitHub authentication for OICD, I think it is. I didn't put it in my notes, I don't remember.
Yeah.
OID.
Wait, DC, not CD, right? Yeah, always get it wrong. So this was the least effort, in the long run, the least effort for us. But it was a lot of effort to get this set up and get it running and working out well. But in the long run, it's very easy for customers to start. The onboarding process is so much easier, and we don't have to copy-paste files all over the place. Another problem for our customers is templating. So you've probably all written like deployment configurations, just service configuration. At KubeCon there was a lot of joking about YAML engineering, etc. I guess you all recognize that. So let's say you have your deployment, and well, it's green. I don't know if you showed, or blue actually. Next one is green. Let's say that you have a fairly similar set of deployments. It's slightly different. You can copy paste. That's fine. Find and replace. Totally fine. But what happens when you have many different deployments that are just slightly different? Then you probably want templating. And I can tell you right now that Helm is de facto standard for templating. And if you're thinking about templating, you probably should look into Helm. But our users, do you think they cared? So they went Terraform. Because they use Terraform for their infrastructure, and that's how they set up things right now. That's what they use currently, and that's what they used to. They're not interested in learning Helm. They already have something that works, so why can't they just use it? So the Terraform Kubernetes provider, it's good, but it doesn't support alpha nor beta features. And we rely heavily on beta features in our cluster. So in order to make this available for them, we needed to extend the Terraform Kubernetes provider. And I'm not really happy about it, but until recently they announced that they're going to support beta features to some extent, and I hope by then we can stop supporting this. But in order to make our customers happy, this is what we needed to do, and in order to make Kubernetes an option for them currently. So remember when I said Mesos Marathon? It's coming back. So what our users were used to when they had Mesos Marathon was that the flow of deploying something to Mesos Marathon was to make a commit to a specific repository that called Marathon site. And when that happened, a build triggered that would then deploy to Mesos Marathon in the end. And this is a flow that has been established over many years. The vast majority of our engineers are very used to that type of flow. So they really wanted to add some kind of GitOps to the Kubernetes experience. When we came and told them that you can just do kubectl apply -f and then you file, they were not that happy again. It's like so unhappy developers all the time, very demanding. So what we did was that we did set up Drone.io. It's a CI/CD tool that is very good. It builds on Docker images, and if you use that Docker image which has kubectl applied, and you give it like a service account secrets, then you can use that to follow the exact same flow that we had from Mesos Marathon. And our developers were super happy. So, time to market. This is, I think, the second most buzzworthy word in my slides. But time to market matter because everyone wants something yesterday. And especially when you start talking about, we're going to start running Kubernetes, and we're going to move everything to the cloud. People want it to happen yesterday. And in the beginning, we were not that comfortable with calling our Kubernetes cluster stable. We didn't really want to tell people to run all the production load on it right away. Because what if something happens and everything will be down, not happy. So when you are delivering a service, there's like a fine line between keeping the attention or the want up for the service while still delivering in time and being able to take the time to do the development that you want to. And if you are not the first to the market, then you need to be better at something. You need to be tailored closely to what other services that you provide. In our case, we made it super easy to send logs from Kubernetes deployments. It's just you add an annotation, and then your logs gets to either production, staging, or development environment. And you can even define what type of parsing you want on it. Or you make it do more than whatever you scale longer. anything to make it better than what other options are out there. So you're not only competing with time, you're also competing with quality. I want to tell you about the ambassador. I think this is a really important part, and I'm very happy that we've found one. And it could be one of your first adopters. And if you find someone that actually, really loves your service, they really like it, it's the best thing since sliced bread. And if you can get, those people to really talk about it and lead the way for other developers, and to make a show this is the way that I do it. It works well for me. And if they are perhaps also someone that has a good reputation within your engineering team, someone, maybe a principal engineer, that's lovely. And I think it's also very important that you give the love back to them. When they provide you as an ambassador, you need to give them space and the resources and the tools to be able to continue to do that work for you, because it's very valuable for you as a service owner to have someone to promote your service outside your team. It will help you so much more in the long run. And communication matters. It's one of the hardest things to do in software engineering, to communicate well. But what we try to do is that we try to write a lot. So we try to write blog posts and documentation, not talking about quantity, I'm talking about quality, but still we try to write it written, because as I told, we have plenty of time zones, we have plenty of different offices, we cannot be everywhere. So we try to write it down and make it available. And we try to broadcast. We have sprint reviews every other week, and we actually broadcast those and record them, and then publish in a blog post with recording. And we also try to record some presentations. If we're given an introduction on getting started in Kubernetes session, we try to record it and have it available in case someone new joins a team or another team is getting onboarded. These materials are available. And we try to visit if we can. And we do sometimes have something that we call enablement collaborations. That is when we meet up with a team for similar to Focus Week, but instead of finding out their needs, we're going there to help them learn and understand and use the services that we provide. As I said, Kubernetes is only one of the components that we provide. And speaking of visiting, twice a year we have an internal conference that is called DevOpsCon. It's a very, very innovative name. Last time was in Toronto last year. And when we go, we try to go and prepare a lot. So we prepare those presentations. And we prepare a lot of materials and workshops that we can offer to the other attendees. And since it's an conference, we're not pushing it on anyone. We make the offer, and then they can pull it in if they're interested, and if they want to take part of this. We also answer to requests on I'm trying to figure out how this thing works. Can you sit for me for a while and we look into it? And we try to be as approachable and available as possible when we go there. I want to talk about when shit hits the fan. No one had a production incident, anyone? No? No?
Of course.
So, I don't know if any one of you remember this one. This is from 2017. GitLab accidentally deleted the primary instead of the replica. And the first backup failed. The second backup was nowhere but to be found. And something like that. The third one worked out, but it took them way too long to recover. What they did do that I find very inspiring is that they did not hide this, like some other companies that pretend they don't have an outage. But they did actually, this is just a print screen of that one, you can find it on the URL at the top. And this is very brave, and I think this made them come out looking better than when they started. And I think that's amazing for a company that deletes the databases.
Was it them who were live broadcasting what their engineers were doing, like
Yes,
trying to recover.
there was an engineer
Yeah.
broadcasting the work of trying to recover the state.
They had a live Google document where they
Yeah, true. They were
had-
documenting
said, okay,
everything.
we're going to try this thing and that
But
thing.
there was also a Hangout Live.
Mhm.
Oh,
Yeah, they were also like streaming it on video.
Yeah.
Alright, that's cool.
Next level.
I only followed the document. That was
A lot of
brutal.
pressure.
So, when shit hits the fan, we took inspiration, actually. We had a little incident with Helm. So we used to deploy all our backend namespace configuration using Helm releases. And when they screwed up, and when you delete a Helm release with purge, it deletes all resources associated with that. When namespace is one of those, it deletes all namespaces. Which means that it deletes all the ports, all the services.
Pretty much.
Pretty much it was the quickest wipeout of a Kubernetes cluster I think everyone ever done. But we took inspiration. We thought this is not the end. GitLab did it. They survived. So we actually wrote a postmortem and we emailed it to everyone in engineering. And we got this back. Thank you for sharing this in such a transparent manner. It's great to see that Foundation takes the responsibility for the cluster very seriously. It continues. So while the service went down, and that of course is problematic, I actually do trust the service more now due to this communication. And this is written by a senior engineering manager the day after we published the postmortem. And I'm actually really amazed by this because we did something really bad. And we actually came out with someone trusting us more on the other end. I think that just shows how important it is to be transparent with your users, to share what you're doing in an open, honest way, not hiding things, details. That does not mean that you blame anyone, that does not mean that you openly blame yourself. You just calmly write down whatever happened, and you state it as facts, and then you share that. And you also tell people what you're going to improve in the future for this to not happen again. And by that, it will actually create more trust in your service and make people more likely to feel like you're doing your job well. So this is my quote, and it's transparency leads to trust, and I think it's very important. And it goes everywhere, but I learned it especially with this. So the last thing I want to talk about is to share the love. And you can imagine that in many different ways, but the thing that I think about is, let's say that you have like a Slack channel that's private, you only invite your own team in it, and then you take whatever you can find that says something positive about you. Imagine that, let's say it happened. Then you might find in a different channel someone writing, slow elastic beanstalk deploy is driving me nuts. Okay, this spoiled me. Or Foundation, just so you know, again, love drone, love Kubernetes cluster. So easy to do stuff. And these things are important to remind yourself that you actually do deliver a service that people like, and you know by the end of the day, especially after you wipe out all these pieces. So, thank you so much.
So today I'm happy to host a talk about introduction to Istio. How many of you guys have heard about service meshes overall? Right, so who does know more than 4 service meshes? Right, so is somebody using service mesh in production? Oh, well, yeah, that's great. Cool, so Istio is one of the out of 10 service meshes that I'm aware of, at least at this moment. So yeah, as usually, quick agenda. So I will talk a few words about monoliths, few words about microservices, what are the service meshes, Istio and components of it. There will be a quick demo, also additionally Q&A, and that's basically it. So yeah, who am I? I'm Piotr Kieszczyński. I'm a cloud architect at NordCloud. I've been working here for almost 2 years. Actually, in June I'll be celebrating 2 years. And I'm living in Poznań, Poland. Well, we are a distributed company, so here I am. And you can find me anywhere on the webs under Kieszczyński, like Twitter, GitHub, whatever there is. And on a daily basis I work with Kubernetes, both on AWS and GCP, with service meshes, and helping our customers to get to the successful project. Right. So just a few words, if somebody was living under the rock and never heard about the microservices. So you know about how things developed over the last decade or so. With the software architecture, we don't do monoliths anymore, or try not to tend to do. Nowadays we are more like microservices oriented. And when we changed our way of thinking in building application in software engineering to microservices, then we encountered different sets of problems that we couldn't predict before. So typical monolithic application, whenever there was a bigger change, we need to write it down from top to the bottom. And yeah, like the scaling was bad, except for like vertically with up 1, up 2, up 3, and manually switching between the nodes and all the pains that you could ever imagine, like code freezes for 3 months. Yeah, been done, done that. So are the same microservices yet another nightmare? Well, network never fails, right? Because well, we just switch over from like EBS to network, and that's fine, totally. We put everything that was logical to API, that's fine. Latency, what's that? Network? Yeah. Unlimited bandwidth, cool. So everything is now API or GraphQL if you are in like the modern kids. Yeah. And well, overall networking, we don't need any more Cisco people like that knows the Cisco ASA stuff and whatever there was. Because we have SDNs now, like Calico, Wave, or any other. And if we put that everything into perspective, like we have Java and JVM inside the Docker on some node in the cloud somewhere, and yet we are still more far away from our code. And if you put the networking into consideration and trying to debug it, and with the networking, the cloud, SDNs, endpoint proxies, like which is the part of Istio, service meshes, yeah, that's gonna be fun. Right. So how do you run microservices? So first step that I saw is, okay, let's call it a microservice, let's put our monolith into the Docker container. It will wait for like 5 GB because this is one big var file. And we are doing microservices. Instead of doing yum install or unpacking the package, yes, we are doing Docker pull which contains Tomcat, and that's fine. And actually, that's fine as the very first step. We can also do metal, like blades, whatever, VMs, PaaS, which is like Heroku, Days, any Cloud Foundry, there are like a bunch of those tools. And we can do containers, right? So, well, containers are cool, like, because containers are like 30 years old. We used to have JSON, BSD, roads, OpenVZ, things a lot, but this is not actually the part of the talk. But yeah, you heard about Docker. So, well, Docker is not only container engine that is used nowadays. There are like also an Architect and Container T, Run C, yet another standard, and so on. So Docker by itself is not enough because it's cool, it's working closely on my local machine, so let's deploy it somewhere else. Right. So there used to be a time that most of the developers didn't know there was a word beside localhost, So if you go to the two-node setup, many node setup, how do you scale? How do you schedule things? How do you implement service discovery? That's actually built in Kubernetes. How do you monitor those things? Health checks, debugging, do SSH into container? So, well, Kubernetes by itself solves a few of those problems. By the way, Kubernetes is Greek word for pilot. It's based on Borg, which is Google internal tool from provisioning the VMs, containers, all the things. And one of the nice features is that it's platform agnostic, so it doesn't matter in theory that if we run it on the private cloud, public cloud, mix of those, bunch of raspberries, it's fine. It's like the OS for the cloud, that we have unified interface that we can communicate, and just everything will happen automatically under the hood. So it does include like scheduling of the pods, lifecycle of the pods, the states on those, scaling, built-in service discovery, load balancing with service meshes, communication with the cloud for like volumes of different providers of the disks like Ceph, Cluster, and built-in some EM capabilities, which is like airbag or communicating with any other EM that we want to merge with it. Okay, we implemented Kubernetes. We spent 10,000 man days on installing our own pet stack, but well, let's scratch it because it's not Kubernetes anymore. So yeah, what happens if we go to the bigger scale? It's fine, we run a few services, we are the first adopters. Well, what happens if you go to the scale? Because managing 500 microservices is not humanly possible. There was this calculation back in the days that a single person can handle about 50 physical servers or something like that. That was the actual, when you build a team of ops people, like, or sysadmin, more like it, that it depends on the amount of servers that you had to hire X amount of people. Nowadays, with even fewer people in operations can manage more, but this is not good yet. Cool, so what we can do? So there are things to consider as well, like request routing, managing failures, A/B testing, or blue-green, red-blue, depends on the company, tracing, logging, and we created yet even more problems going into the Kubernetes that solved a bunch of those. But well, we created even more. So how we can help that? So we are introducing service meshes. So what's actually a service mesh? In theory, a service mesh is just a network that controls communication between the service to service, and that's all, basically. Like it has some features that are already in Kubernetes, like service discovery or load balancing implemented, but puts it on another level. In previous talk, there was like mentioning about the security, and with Istio, for instance, we can introduce a lot of security with mutual TLS in our application with actually one line of the code, which is labeling the namespace, and then we need to recreate the pods, and we have like totally fully secure application out of the box without re-implementing anything else. Cool. So I will show you a few of the most popular tools that are out of the market. One of them is Octarine, the next one is AspenMesh, Istio, and Linkerd. There are a bunch of more, but I think those are worth mentioning, and actually the lower one, like the Istio, is the most popular one, so you probably heard about Istio most often rather than any other of those. Right. Cool. So what are the perks of using service mesh? Well, in theory, it simplifies the communication between the services. but the learning curve for that is kind of harsh in the first place, especially with Istio. With other tools like Octarine, it's way easier, or Linkerd. We can easier diagnose what's going on, why we are hitting like 500 on our internal service, and yeah. And overall, most of the service meshes which are implementing, like putting a sidecar next to our container is quite good design at this moment, unless we figure out something better. And it allows us to do like A/B testing with our services. We can do that with like beta users as well on production if we want to do. We can put like weight-based load balancing, which is built in Kubernetes by itself, and we will have a quick demo of those. What are the cons? And the main consideration is that the performance of service mesh, because there are not that many researchers yet about, okay, let's put Istio. We have a production, let's put Istio on top of it, and what is actually the cost of runtime. As I spoke to a few guys on KubeCon, well, the IBM guys said, oh, it's like 5 to 10% of CPU. And that's it. It doesn't matter if what's your workload, if it's 5 pods or 5,000 pods or 50,000 pods, it's 5% of CPU. Right. Well, moving on, like there is a project called Meshery, which actually does the performance testing of service meshes. So I encourage you, if you want to get a little bit deeper into performance of service meshes, then yeah, Meshery is a way to go, at the moment at least. Cool, so let's talk about Istio. Why Istio? So Istio is yet another Greek word, which is sailing, pilot sailing, you know. And it's a service mesh, it's open source, does support authentication, routing traffic, and enforcing policies on rolling the certificates and so on. So Istio contains at least 4 main components: proxy, mixer, pilot, and citadel. And most of each of this component is yet another microservice, and depends on the so depends on the component. It does a different thing, right? So starting with the pilot, it actually observes the pods, sends configurations to sidecars, and that's it. The mixer is to enforce the policies and sends telemetry data like metrics to anything you want, like Datadog, Stackdriver, Prometheus, and yeah. So Citadel is built in Istio certificate authority, and all the thing you need to remember from that is just to we don't have to manage any certificates by hand. It's being rotated automatically by this component, and that's it. And Envoy proxy, which is like, as I mentioned earlier, that we inject a sidecar next to our pod. That's what istifies the application. And this is actually the pod, the Envoy proxy. And yeah, that's what it does. Cool. So let's have, does anybody knows the Bookinfo application? Yeah. So as usually in every demo there is a Bookinfo application. This is a bunch of microservices written in either Java, Ruby, Node.js, Python, doesn't really matter. But the main thing to remember is that we have a free version of one microservice for the reviews. And the difference is that in version 1 we don't have stars, in version 2 we have the black stars, and in version 3 we had red stars. That's what's going to differentiate if we have which version of the service. And what's the architecture with the Istiofied application? Actually, we inject the sidecar proxy next to every app, and we introduce different kind of CRD which actually on the cloud is a load balancer, but it's Istio gateway, and that's basically it. Cool. Any questions so far? If not, then we can go to the demo. Alright, so I should have, so this is a Google Cloud Console. I have a really fresh project that was created today. I just enabled APIs and created a fresh back Istio cluster. There are not that many things to be specific to set it up, except for VPC native. But why I choose Google? Because it's, well, in my opinion, the best managed Kubernetes cluster. And if you want to try it by yourself, just get a free trial with $300, and there is this tick, enable Istio beta. So if you don't want to do that manually or whatever, you can just do it with Google Cloud, and that's totally fine. And this cluster, instead of AWS won't spin up in 20 minutes just for the masters, it will take 5 minutes tops. But yeah, I didn't do that because I want to show you how rather simple and easily we can do that. So, unfortunately, since this is demo, I need to make a few copy-pastes. So, I just get a fresh cluster. I don't have anything in that. KG is kubectl get shortcut, so don't worry about that. The namespaces, yeah, we have nothing in there. Cool. So let's start with installation of Istio. So this is typically specifically for GKE only. We need to set up our Google Cloud email as administration in Airbag in order to manage Airbag accounts. It doesn't matter on any other cluster than Google one. Right, so I'm Airbag admin now. I will skip the boring part, which is downloading the Istio locally and so on. So let's install it. Obviously, we need to enable Tiller firstly for the service account. That's why we enabled ourselves as Airbag in the first place. And let's deploy Tiller into our cluster. So Tiller pod is running, as you can see, Tiller deployed. I'm still waiting for Tiller 3.0 when we don't have to do that. Yeah, Tiller was CI/CD that we enabled for that. I read an article yesterday. So cool. So let's use Helm because Helm is really cool. And let's install Istio. Since it's demo, we don't enforce NTLS globally, obviously. We install a few more tools that doesn't come with the beta one, which are Grafana and Kiam, great for visualization and selling to your C levels why I want to introduce Istio to our company. Right. So let's see. I should get a new namespace, which is Istio system. And we should see some pods soon. It usually takes 1 minute or 2. Obviously, I should use Helm over TLS as well. And yeah, this is, since it's just a demo. So things are
spinning up. As you can see.
So was there any specific reason you didn't enable it now?
Yes, because I didn't enable enforcing because, well, in the first place I want to show you guys the multi-cluster thing. And since I don't know how to delegate the MTLS between different two clusters, that's the reason, basically. There are some things like you need to have in the same region, like in GK if you want to have a multi-cluster setup, that's what makes Istio fun, like you can do that. Yeah, so it's deployed. Cool. So let's do the let's Istiofy our whole environment, which is like putting a label on namespace. And every pod that will be spawned will have one more container for Envoy proxy. So yeah, now we'll deploy the bookinfo application, so I don't need that actually. Let's see what's actually in there. So a bunch of services, yeah, like product page, and so on, so on. Nothing fancy. So let's run it. Not just that. Yeah. So we should see that we should have a bunch of resources soon. And in so-called meantime, let's and let's deploy also the gateway, which is like CRD from Istio itself, which is like the entry. It's like ingress load balancer for the Istio. So we should see our application soonish. And also need destination group. I won't bother you with all the different things that are inside of Istio with all the customer resources definitions that are in here, because, well, we don't have much time to do that, and if you want to look it up, there are docs for that as well. Cool. So, let's see. It seems to be running. Yeah. There should be like publicly available. Yeah. Yeah. So seems to be running. So we're actually hitting like only the first version, third. Second, and so on, so on. It's publicly available, so if you want to have test it, go for it. But since we don't, now we specify the default destination round that are in the examples are just going one by one the round robin way. So we can actually ship the traffic, and that's what makes Istio really cool. So. Yeah, let's ship the traffic. So now we specify in our virtual service that we want to go to the reviews only to version 1 at the moment. So if we apply that and just do it, we will every time we'll hit just the version 1, right? Okay. We can also do the like weight-based routing as well for that. So we see. We can select like, okay, for the reviews we want to ship traffic 50-50 between version 1 and version 3. So let's apply it. And now, well, since I'm hitting like just every other second probably, totally it will be like 50-50. So as we can see, it's rather halfway between those services, right? Cool. Also, we can do like the, based on the header, based on whatever we want. But let's make sure that we can see any logs or statistics, metrics for that. So on my console, I actually run the kubectl proxy command. So by default, we have built-in Istio Grafana as well, so we don't need to configure that. If we do the enable on beta, there is not built-in. You have to configure it manually. At the moment, we don't have any operations, but let's make some traffic to the cluster. Which would be like basically core in the loop.
We can't see what you're typing.
Yeah, I'm just changing the IP.
Okay.
Because, well, the service changes quite often. So let's make a bash stress test, right? So this actually we're gonna, so well, since it's iter, we can do that. Yes, and I want to do it. Oh, yeah.
Nice.
Yeah. Cool. So I should see some traffic there soon. It's running or not? Yeah. Connection refused. Cool. Is it right or I'm looked already? Whoops. It's that. Yeah. Actually, why? Right. So yeah, let's check on the Grafana if it's, if we can get some more hits or even less. Well, you can see something's happening. Like, yeah, operations. Yeah, actually, I usually use Locust for that, but I didn't have much time to set up on the cluster with that. But yeah, curl is fine. And the most important part, if you want to sell to your business, Istio, the visualization is actually the Kiali. So it's, there is like service graph that used to be in Istio. But yeah, this is how you can visualize your application without touching any line of the code. Actually, if we do some hits on the side, yeah. Let's see. we should see, because we are now splitting traffic between version 1 and 3, then we should see that in Kiali in just a minute or so. So yeah, that's how we can see like what's the traffic shifting or how many ops are for each of those, like between the version 1 and version 3. Also on Grafana, you can see. So yeah, bunch of cool stuff. And actually with Istio, you can do multi-cluster services, which is, okay, we got different version of our application on different cluster. And with Istio, by its design, we can shift traffic to other cluster with this service. So there are some use cases for that. But yeah, if you want to play around, just download Istio. Those samples are on their website. Book info is quite popular. Want to play with GKE, just enable Google Cloud. And yeah. Cool. So it's not running. This button. Yeah. And one more thing. I'm glad that I have my browser in Polish so you can understand my browser history. And yeah. Any questions? Yeah.
Have you used Istio in production in a large scale, and what kind of problems are you normally facing? And in general, how production ready do you think that Istio is?
Well, based on all the service meshes, I think the Istio, I actually used that in one customer in production. The scale wasn't that big because it was something between 50 and 100 nodes with even half of the pods inside of it. I would say depends on your scale, it's production ready because in terms of performance, actually the telemetry and policy enforcing is most data consuming. But if you don't go that big of a scale, I would go with it. And why Istio over any other? Because even if the learning curve for Istio, debugging is not that fun, it's hard to understand in the first place. Well, since it's kind of inhabited by Google, then it's gonna be fine at some point, at least. But that's the reality of the market, right? Like, why choose Spinnaker over Jenkins? And so on. Why choose Istio over Linkerd? Because Google inhabited it. Well, let's get the experiences for like the hyperscalers. Don't reinvent the wheel. They already fixed that issues 10 years ago. Right. Any more questions? Obviously, all the commands are on my GitHub. So if you take a look at Istio webinar, all the things that I copy and pasted, not typed, because I get fat fingers, they are available. The presentation will be available as well. I'll just send the link to the Meetup. And if there are no further questions, thank you for your attention. Thank you for your time. If you want to follow up, just ping me anywhere of those, either LinkedIn, Twitter, GitHub, whatever. And yeah, thanks.